Hey guys, so welcome to the very first lecture for probability. So the very first question says, draw a tree diagram to show all the possible outcomes of boys and girls in a family that has 3 children. Okay, a fairly simple question to kick things off. Okay, so we have the first kid can be a boy or a girl, okay? Then that could branch out to the second kid. So that could be boy and girl again. And from the girl's perspective, again, if the first one was a girl, the second one could be again a boy and a girl. So that's the first kid, and that's the second one. And then from again, if they have 3 kids, that could be boy, girl again. This one can be boy, girl again. Same thing for this one. And then same thing for this one. Okay, and that is the third child. So the possible combinations, guys, is boy, 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 girl, etc. So let's write this out. So we have possible outcomes is boy, 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 or boy, boy, girl. We can also have boy, girl, boy. Then boy, girl, girl. Then we move to the next branch. So we have girl, boy, boy. Girl, boy, girl. Girl, girl, boy. And then girl, girl, girl. So these are the 8 possible outcomes of boys and girls in a family that has 3 children. Okay, so let's move to the next question. This question says, a fair coin is tossed 3 times. What is the probability of 3 heads coming up in a row? Okay, so again, very similar type of question to the one before. Again, we have to utilize a tree diagram. So we have the first flip, that could give us a heads or a tails. Now guys, there are 2 sides to a coin, and the heads, the probability of a heads coming up is obviously 1 out of 2. The probability of a tails coming up is also 1 out of 2. So that is the first flip. Then we have the second flip. Again, it could be heads or tails. So again, the probability stays the same. So 1 out of 2 for the second one. It could be again heads or tails, considering if it was tails for the first one. So again, 1 over 2 and 1 over 2. Again, this expands out. So we have heads and tails. Heads and tails. No, I'll fill out the probabilities in a second. Heads and tails. And then we have heads and tails again. So again, the probability is being half each time. Okay, excellent. Now the question says, what is the probability of 3 heads coming up in a row? So let me use a different color here. So the branches that we are looking at are this one right here. So we're looking at the probability of H, H, and H happening. So the probability of the first H happening is half, multiplied by the probability of the second H happening, which is half again, multiplied by the H happening on the third flip as well, which is half. So we have half times half times half, which is simply 1 over 8. Or the other way to look at it, guys, now there are 8 possible combinations or 8 possible outcomes of flipping a coin. We can have heads, 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 tails, heads, tails, heads, etc. Just like we did for the boy and girl question in the previous one. So there are 8 possible outcomes. Out of that, there is only 1 possible outcome, whether it's heads, heads, and heads. So the probability of 3 heads coming up in a row is 1 out of 8. Fantastic. So now let's move to the next question. Okay, so this question says, if a die is rolled 360 times, how many sixes can be expected? All right, so these types of questions are really common, guys. So we have a die which has sides 1, 2, 3, 4, 5, and 6. The probability of a 6 coming up, out of the 6 possible outcomes, it's obviously just the 1 out of 6. So 1 out of 6 is the probability of a 6 coming up. So 1/6 of the total of 360 rolls will be the number of times sixes can be expected to come up. Obviously, it's not going to be exact because sometimes probability doesn't always match up, right? So sometimes it can be fives coming up in a row, or six, or threes coming up all the time. But obviously, this is how we predict probability. So 1/6 times 360. 6 goes into 6 once, 6 goes into 360, 60 times. So that gives us 60. Therefore, 60 sixes can be expected. Fantastic. Let's move to the next question. Alrighty. So this question says, of a class has 38 students who are doing different types of sports: cricket, basketball, and football. 8 students are doing all three. 12 of the students are doing cricket and basketball, 15 students are doing cricket and football, and 10 students are doing basketball and football. Also, 24 students are doing cricket, 20 are doing basketball, and 20 are doing football. 3 students aren't doing any of them. Draw a Venn diagram to represent this information. Whoa, so we don't have a lot of space here, so let's draw this out as best as we can. Okay, now there are 3 different sports that's being played, so we need 3 different circles within this diagram here. Okay, now I'm going to be using different colors because it's going to start getting a little bit cluttered, so I'm going to use different colors to really signify what we're trying to do. So let's call the first circle can be cricket, second circle can be basketball, and the third circle can be football. Okay, so now let's start using some of the information that's been given to us. So the question says, there are 38 students all up. 8 students are doing all 3. So that's the very first thing we should fill in, because that is the intersection right there. So 8 students are doing all 3 sports. Next, it says 12 of the students are doing cricket and basketball. So we are now looking at the cricket and basketball. So we are looking at this particular, let me use a different color here, this particular intersection there. So that is the cricket and basketball intersection. Now, as you can see, we already have an 8 in there. If there are 12 in total, that means this particular part will be a 4. Okay, now the next part says 15 students are doing cricket and football. So now we are looking at this particular, let me use a red here, this particular portion there. Now, as we can see, once again, we already have an 8 in there, but the next part says there are 15 students doing cricket and football. So this part has to have a 7 in there, because 8 plus 7 will give us that total of 15. And then we have 10 students are doing basketball and football, which is, again, using a different color, let me use a purple this time, is this portion here. This portion right there. And that has to total 10. And we already have 8 in there, so this part has to be a 2. Then it says also 24 students are doing cricket. So let me use a different color once again. Let me go to a blue color. Okay, so they're talking about this entire circle here, which is the cricket. Now that is 24. That needs to add up to 24. So we have 8 plus 7, which is 15, plus 4, which is 19. Then we need another 5 to put into this particular part there. Similarly, again, let me use a different color. Let's use a green this time. 20 students are doing basketball. So that's this entire circle there. And that all the numbers in that circle have to add up to 20. Okay, so we have 8 plus 2, which is 10, plus 4, which is 14. So we need another 6 to go in there. And then finally, we have, let me use a different color again. Let's use an orange this time. We have 20 doing football. So let's cover that. So that's the portion that we need. That already has 8 plus 5, 15 plus 2, 17. So we need another 3 to be doing football there. And then finally, it says 3 students aren't doing any of them. So let me revert back to my trusted white color. And we have the 3 sitting outside of those 3 circles. Now, guys, a good way to make sure that you've captured all the information correctly is to quickly add up all these numbers that you found. If they add to give you the total figure of 38 students, then you know that you've got it correct. So let's do the quick addition. So we have 3 plus 3, which is 6, plus 2, which is 8, plus 6, which is 14, plus 4, which is 18, plus 6, which is 26, plus 7, which is 33, plus 5, which is 38. Bingo. So we definitely have the correct answer. Okay, so what is the probability of selecting a student who's only doing cricket? So that's this part here, guys, which does not actually, what do you call it, go together with any of the other sports. That's cricket in isolation right there. So that would be 5 out of a total of 38. Doing all three sports. So we know that 8 students are doing all three. So that would be 8 out of the 38. Reducing this down, we get 4 out of 19. Doing cricket and basketball, but not football. Okay, so that part's important. So they're doing cricket and basketball, but not football. So the part that we need to look at, so which color do I use? Let me use this blue here. So we need to look at this particular section there, which is, as you can see, is just that particular section there has a 4 in there, which is purely the cricket and basketball intersection. It does not have anything to do with football. So 4 out of 38, which is simply 2 out of 19, are doing cricket and basketball, but not football. And the next one says is not doing football. So not doing football means so we have to exclude everything that is taken up by that orange circle right there. So we can add any of the other numbers. So we have 5. Whoops, let me use a different color here. So we have 5, which is the cricket only, plus we have the 4, which is the cricket and basketball, but not football. Then we have the 6 for the basketball only, and then we have the 3 that are not doing any of them. So 5 plus 4, which is 9, plus 6, which is 15, plus 3, which is 18. So 18 out of 38, which is same as 9 out of 19. So the probability of not doing football is 9 out of 19. Let me write this up here. Excellent. Now let's move on to the next question. So again, guys, this is a Venn diagram based question. If you like, please do have a go at this question yourself, and we'll come back to it in a couple of seconds. Alrighty. So the question says, a class of 35 students is asked whether they like Justin Bieber, Lady Gaga, and Drake. 6 students like all three. 8 like Justin Bieber and Lady Gaga. 10 like Justin Bieber and Drake. 12 like Lady Gaga and Drake. 22 like Bieber. 18 like Lady Gaga, and 17 like Drake. 2 students don't like any of the 3. Draw a Venn diagram and then find a bunch of probabilities. Okay, so again, let's go through the process of drawing this Venn diagram. Okay, so it's a fairly large Venn diagram this time, so hopefully we're not so cramped for space as we were last time. Alrighty, excellent. So we have Justin Bieber here, we have Lady Gaga here, and we have Drake here. Okay, so again, let's capture this information. So it says 6 students, let me underline that part, 6 students like all 3. So that is right there. That is the intersection of Justin Bieber, Lady Gaga, as well as Drake. 8 students like Justin Bieber and Lady Gaga. Okay, so that is using a different color, Justin Bieber and Lady Gaga, that is that intersection right there, which already consists of 6. So all we have to do is fill it up with a 2 to make it into that total of 8. 10 like Justin Bieber and Drake. So that is this intersection there. Now, 10 of them like Justin Bieber and Drake. So it already consists of 6. So we can fill this portion in with a 4. And the next 12 students like Lady Gaga and Drake. So you might have already guessed, that is the intersection right there. So 12 like Lady Gaga and Drake, so that can be filled with a 6, because 6 plus 6 obviously gives us a 12. Then, let's use the information now. So we have 22 students that like Justin Bieber. So let me use a different color. So that is the entire Justin Bieber circle there. That's 22 students right there. So we need to make sure that 6 plus 4, 10 plus 2, 12 are already accounted for. So we need another 10 students to go into this portion here. Then it says 18 like Lady Gaga. So we have, let me use a different color. So let me use a green this time. So this entire circle here is Lady Gaga. And as it says, 18 like Lady Gaga. So 6 plus 6 is 12, plus 2 is 14, which leaves me with a 4 to put in here. And finally, it says 17 like Drake. So let me use a different color here. So that's the orange here that covers the entire Drake circle. And 17 like Drake. So 6 plus 6 plus 4 gives me 16, which leaves me with a 1 to put in here. And it also says 2 students don't like any of the 3, which sits outside. So let me use my trusty white again. It sits outside. So again, guys, a good sanity check is to simply add up all these numbers and make sure that they do in fact add up to 35. Okay, so let's quickly do that here. So we have 2 plus 1, 3, plus 6 is 9, plus 4 is 13, plus 2 is 15, plus 6 is 21, plus 4 is 25, and plus 10 is 35. Fantastic. So we have in fact got the right numbers in there. Okay, so this question says, what is the probability of choosing someone that likes Justin Bieber only? So the probability of liking Justin Bieber only is 10 out of a total of 35, which simplifies down to 2 over 7 using our 5s. Part C, sorry, that's not part A, that should be part B. Part A is the actual Venn diagram. Part C is, what is the probability of choosing someone that doesn't like Drake? So guys, we need to avoid this entire orange circle here. We need to avoid this entire orange circle. So all the numbers outside of it, so that's the 10, that's the 2 there, that's the 4 there, and the 2 there. So 10 plus 2 plus 4 gives me 16, plus 2 gives me 18. So 18 out of 35 is the probability of choosing someone that does not like Drake. And finishing it off with part D, we have, what is the probability of selecting someone that likes Justin Bieber and Lady Gaga, but not Drake? Okay, so let's figure this out. So again, we have to avoid the Drake circle, but we also have to avoid